We began our study of electricity with Coulomb's law, and we've reviewed that quickly in this lab presentation. And then we divided out the little charge to define the electric field. Now, in the unit presentation, we talked about electric potential energy, which was K times the magnitude of the two charges divided by R, not R squared this time, just the distance between them, R. So for more on that, please go back to the unit notebook. We will again divide out little q, just like we did up there. And when we have potential energy per charge, per little test charge, that's K, big Q over little r, and we'll call that the electric potential or volts. And it is measured in volts. The voltage is measured in volts. So we really have four key things here that you should know. The electric force, the electric field, the electric potential energy, and then the electric potential or voltage. For the electric potential energy, we needed a system. We needed two fields, or a field and an object, and we remove one of the charges to define electric potential. Electric potential, then, is a property of the space surrounding a single or multiple charges or a continuous charge distribution. This is the equation you use when you have individual charges generating your electric potential. This tells you the electric potential energy that a source and test charge would have if the test charge were placed at a distance r from the source charge. And be careful to use r here. For force and electric field, you had 1 over r squared. For electric potential and electric potential energy, you have 1 over r. Voltage is the electric potential energy per charge, so if we do the units, volts will equal joules per coulomb. Perhaps you can visualize a volt as a battery that adds 1 joule of energy to every 1 coulomb of charge that goes through it, and that would be 1 volt. We commonly have AA and AAA batteries. And what's the difference between them? Well, they both have the exact same voltage, 1.5 volt. That means that every electron that leaves each battery has the same electric potential, which is the same ability to do work. The AA battery just has more electrons, so it will both last longer and produce more current than a AAA battery. Since the work done on a positive charge by an external force, so that's going to be a force separate from the force generated by the electric field by your large charge Q, since that increases the potential energy, and we'll also use the definition of voltage, we come up with another handy equation. We have voltage is potential energy by charge. Therefore, the work is delta potential energy, the work done by your external force, and that will be Q delta V. So the key equation here is work is Q delta V. Now, the work done on a negative charge by an external force, where delta V is positive, will be negative. The sign of the charge counts when you do the math here.